Hello, guys. How you doing?
Just fine.
We've got another globalist conspiracy tonight.
Uh-oh. Oh no. We're just here to have some fun tonight. We're now we are going to pick on some favorites of perhaps our audience even, but this one irks me. Although it was originally Nick's idea.
That's what I do.
What?
To cause
Just
trouble.
roll the grenade into the room and watch it explode to see what happens.
I've been doing that for a long time. It's fun.
So
And I just
so
walk away most of the time.
well, you're not walking away from this one. You're now
No.
neck deep in the flat Earth conspiracy.
Oh man.
Well, wait a minute. Which way is the conspiracy? That flat Earth is true, and there's a conspiracy to make us believe that the Earth is a globe, or is the conspiracy to make people believe that the Earth is actually flat when it's not?
You were saying something about this a couple weeks ago when we were talking about this topic that you had some ideas about where this came from. I don't know if we want to open with that, but you had some observations that you wanted to make.
No, they're not observations. It's,
Okay.
I listen to a lot of people. And there is some speculation that the whole flat Earth thing, what is a psyop that comes out of I don't know, the deep state, CIA, whatever, uh, to make people believe this. And I don't know what the reason is. I don't care. Maybe it's true, maybe it's not. I can't prove it one way or the other. It's not important to me. So, but I've heard that.
You know, this was one of the weirdest things. I never heard of people actually believing in a flat earth except for the myth that Columbus thought people would fall off the edge of the earth. I heard that myth growing up when I was like elementary school. I never even heard of flat earth until I was a salesman. I was selling cars, and this Christian guy is all about, the earth having, he didn't even believe in the spherical earth, like the disc. No, he believed in like literal four corners and like burnished bronze, somehow a dome over the sky. And there's all this conspiracies that no, the sun, Earth doesn't travel orbit around the sun. No, the sun orbits around. I'm like, wait, what? I'm like, what? He's like, no, that's what the Bible says. I'm like, no, no, it doesn't say that. Okay. So I was shocked. I was like, I've never heard these
And
people existing before.
he was talking about the firmament.
Oh,
The firmament is that big copper dome over the earth. Don't you know that?
okay. Okay. Man, there's a copper shortage. We should be sending people up there to kind of get some of that copper.
Oh, that'd be bad. Can you imagine what would happen if you cut a hole in the firmament? Uh, all the air would bleed out. But you see, the firmament has to be a dome because as an engineer, I know a dome keeps pressure. We can't have a flat firmament. We have to have a domed firmament. So in order to have a flat earth, you have to have a spherical cover. You know, and we know this from football. All our stadiums are domes. The big ones anyway.
Yeah.
So the roof has to be a dome, which is like half a sphere.
What about the other half?
The other half is flat because that's the Earth.
Oh,
And I've actually seen that it's a popular meme now. These flat earthers carry around these pendants with the flat Earth, and then there is a half dome over it.
there's no four corners though. I thought a lot of them they go for the bot has to be a literal four corners. Well, why? You know, why not a square?
Maybe they don't
all
have
maps are
everything.
square, aren't they? Because all maps are square, pretty much, aren't they? Or rectangular.
Yeah, true enough.
Nah, they're just trying to get the. I think these globalists, these non-flat earthers, are just trying to convince everybody that all those maps are bad. Not really. I'm joking.
Oh, okay. Well, but the question, I have heard that seriously from people before. The question would be, and I think this kind of gets to what Steve was saying earlier, to what end?
Why?
It's
Right.
just it's to prove people are gullible and they'll believe anything. Well, shit. I don't need to prove that. I just know that's true.
Yes. Okay, Tacticus. The pear-shaped Earth thing. Oh, okay. The Earth is actually a little bit pear-shaped, and it has to do with the axial tilt. And we're going to get into axial tilt later. But think about it this way. If you were to hold Earth in your hand, if it was the size of like a pool cue or a pool ball, a cue ball, the Earth with all of its mountains and its valleys and the deepest oceans would be flatter than a pool ball. This, a pool ball, they're pretty flat, slick surfaces, right? The Earth would actually be a slicker, flatter surface than that. The Earth is huge, and I think we forget that sometimes. If you were to take a standard, the size of the globe that you had in your childhood classroom growing up, that 12-inch globe, and if you put two dimes stacked on top of each other and you held that up, the ISS orbits at the height of two dimes above that globe, that 12-inch globe. And that orbit varies between like 150 and 200 miles up or something like that. I forget the exact numbers, but it's a long freaking way up there. And that's two dimes on a 12-inch globe. The Earth is freaking huge.
Well, there is a bulge of water at the equator.
Yes, there
and
is.
That's due to the spinning of the Earth. You got some centrifugal force, and so the Earth is actually the diameter is larger from across the 2 points on the equator than
Yep.
it is between 2 points on the pole or the two poles because it's spinning. You spin a string and everything flies out to the edge. Well,
yeah,
weight on a string. Same principle.
And on that, and for you flat earthers out there, this is a very easy experiment to do. Just take any sort of plastic sphere, like a basketball, and if you spin it up really fast, you build a device, you catch it, and you just spin it up really fast, you will see the sphere start to go oblong shaped. The center of the spin will start to stretch out. That's like you can prove this to yourself with a simple visual experiment that you can see. And I want to talk about that for a second because everybody just goes. One of the most common things I hear from flat earthers is, well, like, man, all you have is video evidence, man. You haven't seen it with your own two eyes. Actually, that's bullshit. I'm a pilot. And I have said that before publicly many times. And I've even offline showed the guys the ticket. I'm not going to show it because that has personal details on it. Won't show it publicly. But okay, I have seen with my own 2 eyes the curvature of the Earth. You don't even have to go up that high. Steve, this is a story that kind of involves you a little bit. My dad and I were flying across the country, the United States. I needed to build some hours for a ticket I was working on. And
Okay.
I had 2 choices, either circle around over my airport for 50 hours or fly across the country. And I said, I'll do the interesting thing. I'll fly across the country. And so, of course, we had to, we were flying from Great Falls, Montana to Fargo, North Dakota, which is where we were going to overnight that night. Now, I admit that with mountains, the mountains break up the view of the Earth. And so it's hard to see the curvature of the Earth at 12,000 feet. But as Steve can confirm for me, as soon as I get over the Dakotas, what happens, Steve?
Well, I live in the Dakotas. It's flat Earth. Red River Valley. It is like tabletop, almost tabletop flat. You can drive for about 20 miles before you hit any appreciable elevation change. All the fields are just flat.
So Steve, you're saying you believe in the flat Earth because you live in a flat place?
Well, I would. Except there's one difficulty. Because I'm a truck driver. So I drive north, south. Okay. There's nothing to change road directions. You don't have to drive around. Well, in Minnesota, you got to drive around some lakes. But North Dakota, not so much. So east-west, that's pretty good. Roads are straight. North-south, you drive about, I don't know, every 30 miles, you're going straight, and then you got to turn. And you got to drive like half a mile or something like that, and then it goes straight again. Is there something about they couldn't fit all the sections in a grid, and they had to do these correction lines like as you go further north, everything had to shrink a little bit. So, kind of says that things are not flat because of the survey crews knew this. For some reason, this conspiracy goes back, if it's a conspiracy, this flat Earth, goes back to the survey crews. They were in on it when they plotted out the land in the United States, because you just go to an old plot book, look at your section lines and your counties, and every once in a while, the 4 corners don't line up. So were they in on this conspiracy too?
All the way back in the late 1800s when we were surveying the state lines, you mean? Like,
well, yeah, it would have to be.
Yeah.
Because, okay, that conspiracy goes that far because that's the reason they're in there, because supposedly the Earth is round. So even though I look around and it's flat all around me, you got these jogs. And then the other strange thing is in Fargo, the Red River runs north. Man, I thought all rivers were supposed to run south. But, that's another curiosity.
Well, okay, if the Earth was flat and south was the edge, which is kind of how when they map it, how they show it, then yes, all rivers should flow south.
But they don't.
What? Does the water fall off the edge when it gets there?
I've never heard an answer for that. Because it would have to. It would make sense, right?
Well, there's an ice wall, isn't there?
Oh, right. That the South Pole is really just an ice wall that keeps.
It surrounds the whole.
Well, there's got to be an ice wall at the North Pole too.
No. The North Pole is the center.
No, that's the center.
Oh, Okay.
So all the flat earthers really did was so on a standard map projection, you start at the equator and you move out. And you guys have probably seen the projections. I think the Mercator projection is particularly famous for this, where they take it and they flatten it out and then they show you the actual size of that country versus what the Mercator projection shows. Greenland is like half the size of what the projection shows. So all the flat earthers did was said, well, we're not going to use the equator as our start point. We're going to use the North Pole as our start point. That's really all they did.
Okay. So, can you explain this to me? In the summer, the North Pole gets 24 hours of sun, at least on one day of the year.
Yep.
Well, give or take. I don't know exactly, but it's pretty high in the sky. And in the winter, it's like dark for 24 hours.
Yep.
Where is if the North Pole is the center of the flat Earth, how does the sun not shine there in the winter? What kind of gyrations is the sun doing over this platter that it doesn't shine on the North Pole?
Well, this is the hardest, one of the hardest arguments for me, because it's so utterly stupid. If the Earth was flat, okay, then just as if you were holding a plate up to a light source, the entire front face of the plate must be illuminated all the time, and the back face of the plate must be not illuminated all of the time. In flat Earth, the only way to get sun at any point is to get sun at all points all the time. Oh, Shu, I see a comment from you here. We're gonna get into this. I actually, because I am the nerd and I am a pilot, I have a tool that does all of the flight planning that I can do all my flight planning with, and I've used this since I was in flight school. And it's an example of the difference that we're going to be talking about. That equation you're talking about, they just draw out the results for me. So we'll get into that. So, but Shu is not one of the flat Earth believers.
Well, guys, you want to get into a little bit? I can add some history to this.
Oh, please do.
Oh, is this just a modern, 20th century conspiracy or a modernist conspiracy? They just want to get away from God and the Bible, right? Or some of the flat earthers might not even do that. But there's arguably Pythagoras, who thought the sphere is a perfect shape and talked about the moon, and therefore the Earth must be round too. There's some debate about that. But Aristotle, Steve, I think, was talking about this before the show started. 4th century BC. He taught Alexander the Great. Oh yeah, Thomas Aquinas used a lot of Aristotle stuff. Aristotle's used still in many respects today. He used observations on lunar eclipses, where the Earth casts a round shadow on the moon, as key evidence for the Earth's spherical shape. And
So,
did you have something you want to add?
Well, I just wanted to ask. So everyone knows about Galileo and the heliocentrism. Are you saying that the knowledge of this actually goes back further than that?
Yeah. Yeah, this is the common understanding, Even Eratosthenes, if I say his name right, in 3rd century BC, he confirmed the Earth was round, but also calculated its circumference with remarkably accurate calculations. And he looked at the angle of the sunlight at different locations, I think using like lunar eclipses, if I'm not mistaken.
Is Eratosthenes, isn't he the one who did Cairo versus Alexander, and he used the like an obelisk of a known height, and then
I think so.
He digs a hole, and then you can calculate, based on the movement between the two.
He might not have done the lunar eclipses, but he was. I might be forgetting something there, but yeah, he was mapping the shadow. by the poles, or I think obelisk might be
Okay,
the
Nick,
poles.
but all this proves is that the Earth is round in one direction, not all directions. See, the flat earthers admit that the Earth is round, just not in that dimension.
Okay.
Sorry, I just have to yank your chain a little bit.
So,
here.
so it's round.
So
It's round in the east-west direction and not the north-south.
Yeah, that would appear to be what they're saying, because when you see the flat Earth maps, I mean, they have an edge, right? And we were talking about the water falling off and the ice barrier and all that. So there is a circular edge to all of the flat Earth maps. So the next question I have for the flat earthers: why is it that at night I can take some uninteresting binoculars of reasonable power, point them at the night sky at a particularly bright dot, and I can see that other planets are in fact and indeed round? Are we special?
Yes, we are. Because
Okay.
no, you mentioned heliocentrism. We've got to define our terms here. There's
True.
geocentrism and heliocentrism. Geocentrism is Earth. Helio is sun. So is the sun the center of the universe, which would allow the Earth to rotate around that? And that's a completely different theory. We're not going into. We're talking about, well, flat Earth and geocentrism. So I forgot where I was going after that. What was your question?
Well, the question is, why do all the other objects that we look at in space why are they round?
Okay. Geocentrism. So all the plates are oriented exactly towards us because we are the center of the universe. Everything revolves around us. God decided.
Okay. So the Earth can, so all the other flat plates are they just so happen to be pointing at us in such a way that they are all perfectly aligned, and we see only the circle. We don't see any of the
right. And it's obvious, because if you ever looked at another planet and saw the edge of it, no, all you see is a circle. So obviously it's oriented exactly towards us because we are the center of the universe.
Did we just hit maybe on the psychosis here that the flat earthers suffer from? Now, I mentioned the word psychosis, but if you guys recall from back during the COOF days, a term came out, particularly about, I think it's just 2021, mass formation psychoses, where you could incite entire populations to believe things that were just hysterically untrue. It's an attempt to alter the world and get them to do things that would be.
Are we talking about Transformers and stuff too?
Yes. Mass hysteria was an older term for this.
Yeah.
And I'm sure Steve's going to start pulling up notes on his.
No, I got another thought.
Uh-oh. So anyway, well, while Steve's pulling that up, the thing is so I'm a pilot and I can talk a lot about flying, but I have had flat earthers tell me, well, when you sit in an airliner and you can see the curvature of the Earth from your seat in an airliner, they tell me, no, the windows on the airline, they're fishbowled. It's the fishbowl of the airline window. Now, I don't know if you guys remember, but there was a famous crash back in the early 1950s by a jet called the de Havilland Comet. And it crashed because its windows were improperly designed. And it turns out that there are not that many ways you can design a window without blowing up an airplane. And if the windows were fishbowled, properly fishbowl lensed, then if you look down the side of the airplane, you should see all these bubbles floating out of the window bubbles should be floating out. because that's a fishbowl lens, right? Okay. Have you guys ever actually looked down? Because I do, because I'm a pilot and I'm looking at the control surfaces, but I look down there. And what are the windows? Oh, yeah, they're flat. Why are they flat? Because if you do it any other way, they explode at altitude and the plane crashes. So the windows in your jetliner are not fishbowl lens. They're actually just a really cool piece of Lexan, for lack of a better term. But even if that wasn't true, I could take you up to 10,000 feet in my little Cessna 182, which is unpressurized. It does not need to have any sort of special thing. There's a 1/4-inch piece of a Lexan between me and the outside world, or no, it's not even a 1/4 inch. It's less than that, like 3/16 or something like that. Anyway, it's a very thin piece of Lexan, and it's big. It's expansive. And I can look out in front of my airplane at 10,000 feet, and I can see, particularly over Fargo, North Dakota, where it is flat, the curvature of the Earth. From 10,000 feet, you can see it. Not a problem. See it all the time. And so, people wonder, okay, who has to be on the conspiracy? Every single pilot, of which in the United States alone there are 500,000 of that are licensed. So you have 500,000 people, all of us keeping the secret that I am here, I am part of the conspiracy, and I am telling you that the Earth is round because I've seen it with my own eyes.
Well, and by the way, it's a conspiracy with all the companies launching satellites into space. My cousin works on satellites. Oh, he's in on the conspiracy too. He's fooled our whole family.
Oh, your family bought the lie, Nick? Mm.
Oh man, just man, I guess it's so sad. We all think the world it's a spherical.
So
round,
I'm going to do another flying one, and then I'll let you guys go on yours for a bit. But Nick rolled this grenade into the private chat, and he set me off for a while. So here, we're going to throw this up on the screen. This is actually a trip that I did recently. I had to fly to London, and I was flying, and I flew started in Los Angeles. Okay. So we'll add this to stage here. This, by the way, is a tool for pilots called SkyVector. This is, if I were to scroll in, you would see all the sectional charts. I stare at this stuff. Okay, I can keep scrolling in. I'm looking at Hayes Regional down here in, this is some flat place in the middle of the country. But I can see the weather. That's the current weather at Hayes Municipal. Okay, right. So this is my tool, and this tool tells me all sorts of cool things. Obviously, the weather's pretty good across the country right now. Okay. So this is the route I flew. This is particularly coming home. I flew from London Heathrow direct to LAX. And at various points in the flight, I was sick as a dog, so I couldn't sleep. But I would look out and I said, oh, I knew about 4 to 5 hours in the flight, I'd be over Greenland. And I knew that. Oh, look, there I am. Why am I over Greenland if I'm flying to LA and LA is south of London? Wouldn't a straight line just be quicker and shorter? Right? It would be, right?
Yeah, it would.
Okay, think. Now,
well, maybe not quicker, but
shorter.
Shorter. Yeah.
Okay. So using this same tool, I did my best to try and recreate that short line flight. Now, this tool is for serious pilots. Like, we can actually take the flight plans and use this tool to file them. So it does not allow me to do flat Earth projections for safety reasons. So you guys will see that there is a bit of a bump here coming out of London, headed over to Gander. But we use Gander because that is a major international airport that's used for flying over the Atlantic Ocean. 2,043 nautical miles right there. We can all see that. Excellent. Okay. We get to Gander. Now, it's covered up by Stephenville there, but it's 813 16 nautical miles on to Montreal. Okay. Then we go from Montreal to Lincoln, Nebraska. And then we go from Lincoln, Nebraska back to LAX. Does anyone want to guess? I did the math. Does anyone want to guess how many? So, and then we can see here, of course, that it's the straight line flight. That horrible curved straight line there. 4,741 nautical miles. Anyone want to guess? It's about roughly.
I'm gonna guess 4,091 miles.
4,091 on the other leg. Okay.
Oh man, my guess was.
But how does that work?
Well,
That's
okay.
It's more of a straight line, right? More of a shorter distance between the two on the map, right?
So the actual distance for this routing, I did the math while you guys were chatting a little bit. For the straight line route with 3 airports along the way, which is the best I could come up with, that made sense zooming out. 5,003 nautical miles. The straighter line is 250 nautical miles longer. You say, oh, well, that doesn't sound like much. In airline flight times, that's about 45 minutes at altitude. So it would add to fly the straight line would add about 45 minutes to an hour, depending on winds, to the flight.
But why is that?
Well, if you take a string and you lay it over any 2 points on the globe, and then you flatten the globe out, you're going to get a circle.
Ah.
And so in flying, we call this route right here the Great Circle Route. Because when you take that string between the 2 points and you flatten it out onto a 2-dimensional surface, this is what you get. It is actually more efficient to fly further north because it cost me, an hour less worth of fuel burn, which at 2 tons, no, it's like 20 tons an hour for an A350. Oh, that's an extra 20 tons of fuel I don't have to buy. And airlines are very cost conscious, so they really don't want to buy that extra fuel. So, yeah, Tacticus. Yeah, there's headwinds coming back west too to deal with. So yeah, it could be. I've had flights coming back that are 11, 12-hour slogs getting back to LA they're just, it's nasty. It's not fun. So anyway, I'll put this away now. But so this is called the Great Circle, and we do the Great Circle in flying at any distance. I mean, I could show you Great Falls to Fargo. There's Grand Forks. But Great Falls to Fargo has a, clearing this out would take some time. But Great Falls to Fargo's what, down? I can't find it in this mess. Anyway. Grand Forks, but it even Great Falls, which is almost a straight line.
Yeah,
that's Lewiston. You can tell I didn't have this one set up because I was trying to make my other point. Anyway, we can continue on, but this is a tool that we use as pilots for flight planning. You can see I can do all sorts of cool things here. I can set, okay, I want 300 knots at we'll say flight level 320. There we go. And it'll tell you about how long that total trip will take. There's the distance round trip for the two. Okay, very cool. I could put a specific tail number in there. All sorts of cool stuff this tool can do. Anyway, so we'll put this away now. There we go.
Well, there's the other thing. I made a joke to these guys earlier. Yeah, when you get in your car and you drive someplace and you punch it into your Garmin or even in the car, it's called a global positioning system, GPS. Duh. That's called a flat Earth positioning system.
No, Steve, that's part of the conspiracy.
It's NASA, all these space agencies, the satellites, even Elon Musk. Man, that guy.
That guy's
So-
in on all the conspiracies, though. Like he's
Man, I mean, he's a total government agent. He must be, just for by the way, I'm joking.
You know what? Part of this
it's
conspiracy.
it's all a conspiracy, and you know what? It's not really about the things he's sending out, the Starlink. Nah. That's part of it. It's going to be part of the mark of the beast.
Yeah, okay. I figured this one out. So when they put up satellites, they're not really going into orbit. They're just affixing to that copper firmament, that half dome.
oh
And,
okay.
and you know how they keep them up there? A super powerful copper magnet.
Huh?
Hmm? Well, it's made of copper, so you can't
Yeah.
use a regular magnet. You have to use one of those special copper magnets.
Uh-huh. And satellites are heavy, so that's a pretty strong magnet we're talking about here.
Yeah, well, and it's special because it's a copper magnet. We don't have those here on Earth. Just
Oh,
using them
okay.
for satellite purposes.
So all that faffing about to get satellites in orbit and burning them 1.2 million pounds of fuel, that's what, we just don't have copper magnets big enough?
I guess something like that. Okay, so here's the thing I was looking up earlier. You know what we're doing tonight? What is the logic we're using here? Could it be reductio ad absurdum?
There might be a little bit of that going on our stream tonight.
Okay, let me read this. It's from Wikipedia. And I'm probably not saying my Latin right. In logic, reductio ad absurdum, also known as argumentum ad absurdum, is reduction to absurdity or argument to absurdity. It's a form of argument that attempts to establish a claim by showing that the opposite scenario would lead to absurdity or contradiction. Well, that's what we're doing here. We're pointing out all kinds of little glitches in
The Matrix?
the
What?
matrix of the flat Earth. Okay, if it really was a flat Earth, how do you explain these things? And the engineer in me keeps coming up with more of them.
So, Steve, are you saying the engineers are in on this conspiracy too now?
Well, obviously, because I looked at a stream on this in what's the bridge in around New York City? Lorenzo Narrows. Am I saying that right?
I have no idea.
Narrows. Okay, anyway. It's like 1.3, 1.5 kilometer suspension bridge. They put the towers on each end. And, the towers are standing straight.
Yeah.
But, the top of the towers is 41 millimeters further apart than the bottom of the towers.
No, Steve, that can't be right.
They had to take that into consideration when they constructed the bridge.
I wonder what that different distance differential is for the Golden Gate, because everyone knows the Golden Gate.
I'm sure there's some. I don't know.
Well, there has to be.
Measurable.
I've just never seen that number around. Or
No,
are we
Steve,
wrong?
that's just propaganda and lies. Sorry, guys.
Are we mocking? Are we mocking here? We might be mocking.
Absolutely
No,
we
no.
are.
Edge of the world is an ice wall, guys. And every country on Earth has conspired to not let anybody onto the ice wall that circles the disc. Apparently, it's not a flat square, but whatever.
Okay,
The disc.
but you told
And
me
they all conspired. You can't get to Antarctica, which is a big ice wall.
So what about all the
Okay.
people who do live in Antarctica?
I'll
No.
accept that. I'll accept that, Nick. But why is there so much ice at the North Pole, which is supposedly the center? What causes the ice at the center of the disk? Because we don't need ice there to hold the water in.
How come the ice wall doesn't experience summer and winter like the other, like the Earth, like South America and
Yeah,
those places closer to the north, but the North Pole doesn't experience that either. Well, it's not a pole, I guess you could say.
right. And flat Earth, it wouldn't be a pole. But I actually talk to people regularly in Australia and New Zealand. And my buddy in Perth was saying he was griping about today, actually. It's Tuesday there. And he was saying, oh, man, it's going to be 36 degrees. Now, of course, they use Celsius. So that is 36 degrees Celsius, which I'm just going to quick look up what actually is here for y'all. We'll just convert Celsius to Fahrenheit here. Okay, Celsius, 36. So that is 96.8 degrees Fahrenheit for all of you imperialists out there. Doesn't that sound an awful lot like a summer day to you? You know?
Yeah.
Now, it's probably more of a spring day for Nick because he lives in, in Texas. or wherever it is he is down there in the South that's on fire all the time. But it's 97 degrees in Perth, Australia today. So why am I, if the earth is flat, why am I sitting up here in the United States freezing my ass off? It's I think it got up to 48 today Fahrenheit.
Oh, lucky you.
Okay, Steve, what did you get today?
I don't know. It started out 14 degrees this morning.
Oh God.
Might have been up. Might have gotten close to 20. But the wind was blowing today, so it was cold all morning. Well, pretty much all day.
So this weather, it oscillates every year. We get summer for a few months of the year, and then we did winter. We're doing winter right now, and then we're going to go back to summer here in a few months. And but these states in these countries closer to the ice wall, they seem to be really hot right now. What's causing this oscillation, guys? I can't figure this out. You know, my flat plate is just pointed at the sun all the time. What's going on here?
I don't know.
Oh, is that?
Nick has got a solution. Great. I want to hear it.
No, I do. It's magic.
Magic.
God blows
on different parts
cold
of the earth.
winds
Okay.
and hot winds. Right now, he decides for on the outer part of the rim of the circle, hot winds, but it doesn't melt the ice wall. And now, cold winds for the middle. That's why.
And he doesn't ever decide to change this oscillation up. He does it the same way every year. Just it.
Oh.
Nick, are you saying that God is in on this conspiracy theory too? I think that's what you just said, because he does the same. Yeah, you just said that God's in on the conspiracy. He blows cold winds in the north this time of year, and then he moves back. I don't know. Can we get any more absurd than calling God a conspiracy theorist?
So, if I dig a hole and I keep going, I'm going to come out in China, right? Well, I mean, in the global model, right?
You're talking about the antipode.
Yeah, well, there's something on the other side of the world. If I dig a hole deep enough, I don't know exactly, but metaphorically, I'm going to come out in China because it's on the opposite side of the world, right? So I know that when it's sun shining where I'm at, it's not shining at the other side of the world. Figuratively speaking, but since it's flat, it's shining where I'm at, but not over there. But if the North Pole is the center and it's winter time, the North Pole's not getting any sun, and China's not getting sun when I'm getting sun.
Yeah.
So if the sun is up in the sky and it's shining, and we know light travels in a straight direction, doesn't there have to be like a big rotating shutter up there to block the sun from going there?
You need something like that. You
Unless light behaves differently.
Yeah.
Unless you can actually control light and stop it from going in a certain direction.
So
But,
Steve,
if I turn the light down in my room, it pretty much shines in all four corners.
Yeah.
So it can't work that way on the flat Earth because it can't shine over to that, China. So we got to have something up there to block that light.
Oh, Tacticus. No, don't give them Tacticus. I can't put that up. That'll just give them more.
No.
That'll just give them more fuel. No, I can't put that up there. I love the comment. It's hysterical, but I can't put it up there. I don't want to give them the fuel.
No.
So what I have up on the screen right now is called an antipode map. So basically, you just enter your address and you see where you pop out the other side of the world. Almost all of the United States, you pop out somewhere in the Indian Ocean. It's really very boring.
Damn, I don't want to dig that hole because I'd flood the whole area.
Indeed. But yeah, this is kind of a fun little map. Let's do New York, just because everyone knows New York. My spelling's great. Yep. See, there you are. You're still in a little closer to Australia this time.
Australia. Okay.
But yeah, so that's called an antipodes map. That's something you can only do with a globe. Now, people are going to say, oh, this isn't proof of anything. Yes, I know. This isn't proof of anything. I'm just showing this because Steve said digging to China, which is an old saw that we have. And I said, oh, okay, Steve, let's see where you would dig if you, end up.
Yeah.
So, okay, what else do we have in our long list of things that we can share? Oh, we were talking about weather. I've got one. This is one of my favorite maps and visualizations of weather. So I'm going to put this up. This is from a website called earth.nullschool.net. Here, I'll throw it in the chat. There you go. That's a school. I typed it wrong. Yeah, I'm typing too fast today. Nullschool.net. I missed the L in the link. Sorry, guys. Here, I'll delete that so I don't accidentally send you somewhere you shouldn't go. There we go. Okay. So, but this is a real-time map of the winds at any given time. Want to go to the North Pole? Look at the winds. There we are. Okay. Want to go look at the Atlantic Ocean? There we are. So they've got some sort of storm brewing up there. Now, there's an interesting fact that there's an interesting thing this map shows you. that I want you guys to take note. Around the equator here, the wind always seems to be heading west. No matter where I go, right, heading west. Now there's a storm pulling air up here, but you can see even then that air's around the equator, it's heading west. Okay, we're going to come over to the Pacific because it's, yeah, this is a great one right here. That wind is heading west throughout the entire Pacific Ocean. This is a huge number, thousands and thousands of miles, and these winds are just blowing west. By the way, if anyone's ever been to Hawaii in our audience, I have. Maui is, in my opinion, the best of the islands, and no, you can't convince me otherwise. But I always stay in Kihei, which is on the lee side of the. It's on the east or west side of Maui, and that side, and the reason that's the best side to be on is because you are in the lee of Mount Haleakala. So you don't get blasted by wind all day, every day. It's actually just a fantastic place to vacation if you haven't ever been. But that's because the winds in Hawaii are almost always blowing east to west. Now, why would the winds blow east to west? Well, if the Earth is a globe and the day and night cycle is caused by the Earth rotation, then we know from Bernoulli's principle, yes, there's my math for the evening, guys, but Steve knows what I'm talking about.
Yeah.
The air will spin at different speeds on the basis of how close it is to the ground, because air has friction with the ground. So the Earth's rotation causes the air to move, but it's not perfect. So the Earth, particularly here, we talked about the bulge in the oceans at the equator, similar kind of phenomena. So if I pull this up here, we're looking at surface winds right now. If I pull this up, you can see that the winds here are moving slower, but they're still moving in the same direction. If we go, I don't know. Oh, whoa. I went even higher. 10 hexapascals, I think it's HP, it's pascals. It's a measurement of air pressure. So it's just altitude. That wind is rocking. The jet stream, which you guys have probably heard of. Well, okay, there's your jet stream for the day. Yeah, that's, man, sucks to be you. If we have any watchers up in Britain, sucks to be you. You guys are getting run over at altitude. But these winds are rocking up there, but they're rocking this way. Why? Because Bernoulli's principle, the Earth is rotating under the air, and air is just a fluid. For designing airplanes, we don't have any special math. We just use fluid dynamics. Fluid, air is a fluid, and we just treat it as such. And so as the Earth rotates as a globe underneath, you get the air actually wants to, it's what Newton's first law, conservation of momentum and energy. The air doesn't want to follow the Earth, so the winds blow against the rotation of the Earth. Because the air wants to stay in place. That would be its ideal sort of
that
state.
And you do have air moving from west to east over the U.S.
Oh, yeah, you do.
And, it's not that it's got to get back the other way, but it all balances out. It's kind of cyclical.
Yeah. Well, and if you look up here, so this is it's right to left, or left, it's left to, right to left. So you can see that there's a, I believe it's a high pressure system, if I remember my meteorology right, and it's blowing air in this clockwise circle. Well, if we had a low pressure, which up here, which we used to, but we don't today, it'd be blowing the other way. It blows this way. counterclockwise.
That illustrates something else.
Ah,
Since I live in the Midwest, growing up, we'd always have these Alberta clippers. That's what they called them. Now the new term,
this
polar vortex,
right here.
and
Oh,
it would be these strong winds that come out of northern Canada, and just whip down and hit us, right in the middle of the country, and it drops the temperature to 20, 30 below zero Fahrenheit. Oh yes, we're
Sometimes
getting all
more.
this air, but we were seeing that how that swirl, and it changes.
Right there. You said it was windy today.
Yeah.
I believe you.
So if the wind, it's coming from the west most of the time, but if it comes from the north, oh man, in the winter, yeah, you better wear your long johns.
Well, so everyone, okay. Why do hurricanes always hit Florida? Okay. This is actually a great example of why hurricanes hit Florida. And in order for hurricanes to exist, you need a round spherical Earth, by the way. And this is a bit why. So you see how we've got this nice flow here, right here over that's Central America, the Caribbean, right? Okay, and then we've got this strong flow here. Well, look at this band of blue in the middle. Oh, do you notice something interesting about this pattern right here over the Baja Peninsula?
Is that the El Nino, La Nina? I could be
No,
wrong.
El Nino is actually
No,
down
it's
here.
down there. Down there. Never mind.
The reason that
That's just
your
where my mind went.
hurricanes always come, they always come from Africa. They always start down here at the Canary Islands, and they come this way. Well, they're getting blown this way by the upper level winds, and then they hit this landmass here, and they start curling. Okay, just like this. The air picks up from this stream down here and gets curled.
Huh.
And then the hurricanes actually get blown towards Great Britain at the end. We don't pay attention to that in the news here, but the Brits are constantly complaining about it. We get a hurricane, and about a week later, the Brits are complaining about it. So, but this is why there are circles and cycles, but for the equator, the winds themselves are almost always headed east to west. And we used to call these the trade winds. And so how the early explorers, they would come down the coast. There's a reason that they found the Caribbean first. To catch the winds, they would have to come down and over. And then to get home, they had to go up and back. Now I'm showing high level winds, but oh, look. Hey, if you want to go back to Britain, you've got to catch this low pressure system right here, and that'll push you home. And if you want to get from Britain to the Caribbean, oh, look, you've got to come down. And so now what we're also saying, now the mariners of old did not understand, and they didn't, what we know about the earth now, but they used the effects of this stuff. And I use this map all the time. It's one of my favorite visualizations. If you guys want to know what's going on anywhere with the wind is life in weather. The wind determines everything about your weather. I'm sure that comes as no surprise to Steve over there, who is currently dying of wind chill every morning.
No, it's not bad yet.
Oh, it's not bad yet.
Oh, come on. 14 degrees, that's nothing.
Steve,
Hey,
that
we're
that
an
20
hour
below
in.
only if there's
stuff.
wind.
Steve, we're an hour in. I'm going to say
14
this.
degrees is bad with wind.
Steve has a fucked up sense of just how bad it's cold is.
Okay. You know what? I will take 14 degrees in Fargo without any problem. Now, 14 degrees in Texas, that's a different kind of cold.
Oh,
Because you got
that's
the
a
dampness.
humid code. Oh,
That's a humid cold. That is just brutal. But you got to keep in mind when we talk about weather, the temperature up here in the northern states, especially Minnesota, North Dakota, Montana, when it gets frigid cold, the air is very dry. So it's not as hard to live with as like Texas in the 20s. I'll choose up north here any day before that.
I know, but we have to give you shit, Steve.
That's fine. You know,
So
that's a good thing because you know what? You keep up the reputation because it'll keep our population low, and I won't have to deal with as many people.
Yes, that is true. I am looking to move out to a less populated state here because my state's headed downhill really quick. So this is another thing. If you guys just want to use this for like figuring out what your weather's going to do, I have used this to track windstorms. We had a wind event around here. I've used it to track snowstorms, and I can generally tell what the weather's going to be about a week in advance just by looking at this map. This is probably the best visualization, and I have to give credit to an old coworker of mine for showing it to me way back in my oh goodness, this is 8 years ago now. So anyway, I will pull this off now, but that's not the end of my repertoire.
Oh.
I have more, but I've been dominating for a while, so you guys can.
I'll put one thing. We've talked before about long hole. What do you call them? Long. What's your phrase?
Long
Sniper.
distance hole
So,
punchers.
Long distance.
yeah,
hole
snipers,
punchers,
right?
yes.
What do they? We were talking about, the rotation, right, of the Earth.
Yes.
What do snipers have to take into consideration?
Well, I can just give you the list. Okay, you have to take
Oh.
into account air temperature, humidity, wind. Wind is, of course, a big one, particularly at distance. But you know what another big one at distance is? We use spin stabilization to spin bullets, right? Okay. Well, spin stabilizing, it's great, but at distance it becomes subject to something called Coriolis effect.
There.
So you need to take it for shots over about 750 meters. You need to take into account the Coriolis effect of the Earth. And the effect gets much more pronounced as you go further out because the bullet's constantly slowing down from drag through the air. So
Here's another. This is the second part of that. So yeah, we need to take into the. But it's just a dome, right? It's only halfway curved, so there's some curvature. But well, of course, it's rotation. But it's how come it's goes into to the right in one hemisphere and goes to the left in the other?
oh, you're talking about toilets?
Oh yeah, there's that too.
Toilets is the famous one.
Oh yeah.
So Hawaii is fairly close to the equator, and most people in the world live in the northern hemisphere, and not just the northern hemisphere. They live in the subtropic zone, really where the United States is, north to south. That's where most people in the world live. And the further north you go, the more aggressive the spin of the water in your toilet as it flushes goes down. This is another example of an experiment that you flat earthers can do in your own home, the comfort of your own commode. You can do this experiment. Okay. But if you go to Hawaii, it spins a lot slower.
Well, what happens at the equator then? Does it spin at all, or does it just go glug?
It just goes glug. I'm not kidding. It just goes glug. The system still works because it's a suction design, but it just goes glug. And Tactic. Oh, this is a great comment. Tacticus. The answer is yes. Due to mechanical action, it's cleaner to live at higher
Hey,
latitudes.
sometimes you need that swirl action.
Yeah. Okay, guys, we've officially gone off the rails tonight. Oh my god. We're done. We're over. Tacticus, you've ruined us. We're getting banned now. But if you go to New Zealand, it rotates the other way. Well, why is that?
Hmm.
And the swirl action, as Steve so lovely put it, increases as you get closer to the South Pole. So there's something about the poles that are special for the Coriolis effect. And an interesting thing happens there. At the equator, you're actually moving faster through space than you are at the poles. However, the water isn't going forward. It's not like I'm pointing to my right and it's going that way. The water's going down. So at the equator, there's very little rotational force down. At the poles, the rotation and the direction of travel are the same. Does that make sense? So the Earth is rotating around its axis at the pole, and so the lateral force on the swirl is the same as the rotation speed of the Earth. At the equator, it's zeroed out. The force tugging on the water is zero. And then as you go to the South Pole, it's the same thing as you get closer to the pole, except the other way, which you can ironically actually see on that weather map I showed you. The Coriolis effect causes these high pressure and low pressure storms or weather patterns to hit, and that's the same effect. Now, yes, I am hand waving some of the really cool meteorology here that takes years to learn, but
What it seems to me, the deeper you get into science, the more the global Earth and the way things work is foundational. And you can't get in depth and in a lot of fields and accept the flat Earth model because you just run into things. Hey, this doesn't make sense.
yeah. Tacticus has an actual question for us here now that he's got us completely, just sidelined. He delivers the actual question.
Oh, okay.
So are ocean currents more affected by spin or by winds? And the answer is spin. So you've probably heard about El Nino, La Nina. That is caused by warming water coming up off the coast of western South America, and then it gets dragged west over towards Malaysia, that area. And it's the same effect as you see with the winds. The winds in the water are moving they're moving at different speeds because they're different densities and weights, but they're moving the same direction for the same reason. The water wants to stay where it is,
right,
and the Earth's rotation is dragging it
but
along.
water's thicker than air.
Yeah, so it moves
So
at different
it's more
speeds.
affected by the spin
Yeah.
in a different way than the air is.
Right. Aerodynamics. I had to learn this shit 10 years ago. Or, God, no, 15. I'm old. Back when I was in flight school, I had to learn this stuff. So yes, the answer is it's mostly affected by, and it's going to have the same patterns in it. Like, you've often heard about the Gulf Stream which is
Mhm.
the water stream that goes from the Gulf of Mexico up to Great Britain. It's why Great Britain can be at the same latitude as Juneau, Alaska, and not be a frozen tundra for what 6 months out of the year. All that warm water from the Gulf of Mexico is being brought up to Britain and then dropped on them in the form of rain. If the Earth were to stop spinning, Britain would be a lot colder than it is right now. So the Brits better pray that the flat Earth is wrong, because if it's right, they're about to get real cold, like really cold. So okay, but that's actually a good question, Tacticus. After you wreck us, I love it. So, oh goodness, how have we done an hour on this ridiculous thing?
Well, we haven't talked about the moon landings yet.
No. We are not. No. You are a
No.
horrible. You are a horrible human being, Sir Nick. No, we're not going there. I don't need to get. I don't need to get us mobbed in the chat.
Oh, but it's fun. So
We went to the moon. Anybody who says otherwise is tarded. Okay. We can shine lasers at reflectors on the moon, and we can see the lasers come back. Hashtag deal with it. And that's all I'm going to say on that subject, because no, we're not going there.
But okay, can we go here? Did you know that half the population of Canada, or something like that, lives south of Minneapolis?
Yes, I did actually. Canada's. Yeah.
I mean,
America's-
everybody thinks, oh, Canada, that's way up north. Well, okay, Minneapolis, yeah, it's pretty far up north. But most people don't know that the most populated parts of Canada, basically Ontario, is further south than Minneapolis. Okay, here's another
Yeah.
question.
Okay.
I'm gonna ask Nick.
okay. Hope I don't
Okay.
get it wrong.
Which is further south? The southern border of Oregon, or the northern border of California, or Windsor, Ontario? Which is further south?
I actually just saw this.
So you're saying California, Oregon?
The northern part of California or the
Okay.
southern part of Ontario? Which is further north or further south?
Because you're asking the question, I'm going to say Ontario.
Windsor, he said.
Windsor, Ontario.
Windsor, Ontario.
Windsor, Ontario
That's-
lives at roughly the latitude of the Oregon-California border.
But it's just like a mile or two further south. And okay, it's due to that square map, and you're looking
Mhm.
straight across and you don't realize it. But no, because straight lines on that map are not actually straight. There's a curvature there. So
Yes.
no, Canada is actually further south. So if you're in Detroit, downtown Detroit, you go and you travel south, the first foreign country you're going to hit is Canada.
Yep. So somebody did a YouTube short on this, and they actually showed the bridge. The bridge goes south, guys. It goes Detroit south over the river, and then you get to Canada. Tacticus, yes, Canada is the 51st state. That is an inevitability. I don't know if that will occur during this crisis or the next one, but I can tell you right now, Canadian banks are fucked. So don't invest up there. And I call it America's hat, mostly because they hate it.
And the other thing, I lived in Duluth, Minnesota for many years. In East Duluth. you're in East Duluth, you got to go west to get to Wisconsin. Because east west is actually northeast southwest. It's kind of at an angle, but they don't call it that way. So you're going west, and then you can get to Wisconsin. Hey, we got a lot of peculiarities due to geography and whatnot in this world. And yeah, spherical globe is part of that.
The spherical globe causes all sorts of issues. It is part of your life in a way that you don't even realize, and that's what makes this whole thing so ridiculous. I have one more thing to share. I stayed up late last night for you guys, our viewers, just so you could see this. Starlink did a launch last night. Now the launch was at 5 in the morning. Yeah, 5 in the morning, Eastern time. And there's an interesting thing about this launch. It's just a standard Starlink throwing up 20 satellites. Nothing particularly interesting about what's the launch or the payload. But at about 5 minutes and 30 seconds after launch, you can see something really cool. And I'm gonna share this and play this for you guys. We'll hit share here. I'll start the video. We've got our cameras right here. So we've got the stage 2 rocket burning away, and then we have a camera shot looking up where the rocket used to be. It's black. It's night, right? Okay. So if we hit play here, we're going to switch cameras soon. I don't remember exactly when it switches. There it is. Switches to the outside, and you can see this. What's that blue haze? What is that? That's sunrise. Now, tell me what you see. So the grid fin is right here. This is what's controlling reentry. We're still way high. We're 92 kilometers up. We're still way high. So you've got the grid fin right here. What's this curved thing underneath the grid fin, guys? What is that? Huh.
I guess horizon, sun coming over the edge of the earth.
Yes. So when you are 90 kilometers up, your sunrise comes really early, and it's very long because you can see hours ahead of where you currently are positioned. So yes, it is winter in the northern hemisphere, although Florida is nice and far south. So the time shift in winter, which is a fun map. I have it up on my computer at all times because I love knowing how long the day is going to be sunrise to sunset. But in Florida, it's not very long. There's about a 2-hour shift between winter and summer. In Hawaii, it's half that. It's about an hour. It's really strange. When you go from, say, Fargo to Hawaii, your day, if you do it in winter, your day actually gets like 3 hours longer. And so you get jet lagged twice. But this picture is taken from a Starlink Falcon 9 last night. People are going to say, "Oh, that's the camera lensing effect." Get fucked, stay fucked. No, that's not. That's the curvature of the Earth from almost 100 kilometers up, which is I'm gonna convert that for you imperialists over here. But it'll work out to feet here. We'll do it in feet because let's see, this is 92.8. That is 305,000 feet up. 10 times higher than an airliner. And not only is the curvature of the Earth obvious, that's a pretty good, you've started bowing out here. You start bowing out, but by the time you get to this grid fin here, it's already started to curve back under. Now, obviously, when I'm watching this from 10,000 feet out of my airplane, it is not this pronounced. But at this altitude, you can see the curvature of the Earth, plain as day. And look, I know that we'll never convince the flat earthers that the Earth is not flat. We could give them all the video evidence in the world. Because in reality, this episode is not about trying to convince the flat earthers that they're wrong, is it?
No. There's one thing, historic thing that I haven't pointed out, and I mentioned it to you guys. Time zones. Why do we have time zones? Well, I'll tell you why. They weren't even a thing up until the time of the railroads. Maybe they existed, but nobody cared. Nobody used them. They had somebody figure out, oh, what's high noon in my town? And then they went up and set the clock. Okay, that's noon. Because time just existed there. Well, here's what happened. You had trains running from Boston to New York and points further west, and they had train schedules. Well, it was kind of a problem because noon in Boston was different than noon in New York and noon in Buffalo because the sun was at its highest point at different times. So their clocks were all different. So how the hell can you run a train system and stay on schedule if the time is different in every city? It didn't work. Why is the time different in every city? Because of the sphere and wind. Because, hey, we all know sun rises in the east and sets in the west. So the highest point is different as it moves further, the further west you get. So they had to come up with time zones. And if you've traveled at all, if whatever time zone you're in, you're at the eastern edge of your time zone, yep, the sun's going to be up sooner. And it's going to go down sooner.
Yeah.
If you're at the western edge, it's a different, it works differently there. Yeah, it's not up as early in the morning. So that's, again, it's in our day-to-day thing. We've all experienced this on a certain level because every one of us has traveled a little bit. Time zones, and you can kind of see the reason for this. It's the spherical Earth.
Yeah, and if you guys have ever experienced jet lag, or if you've ever flown close to the North Pole, there's an interesting thing that happens so let's say I was flying back and forth to London, and this was September, I think. And there's an interesting thing that happens to you, and that is, okay, September, you're actually getting pretty close to an equinox, so the day is about as long as night. Okay, night should be 12 hours long, roughly. It doesn't quite work out that way, but it should be roughly 12 hours long. Well, the flight is only 12 hours. The whole flight is 12 hours long. It's 11 and a half, but okay. It's basically the same amount of time. But the flight from London to LA leaves at 10:30 in the morning, London time. So the sun is up and it's got a long way to go in Britain. Okay. And you chase the night, or you chase the sun all the way over, and you land. I'm just describing what you're talking about. You land at about 1:30 in the afternoon. Where did those, I just said it was a almost 12-hour flight, but we moved. It's 2:30 in the afternoon, but we only moved 8 hours. Well, we only moved 4 hours. The 8 hours are the time zone difference. That's what that is. And going the other way, LA to Heathrow, you get this really short night. Your night is about maybe 2 hours long. I always stay up for the flights because I'm a nerd and I actually have a trick for dealing with it, for dealing with the jet lag in one day. But I have to wake up really late, leave late in the day, and then you stay up for the whole flight. But that's a whole separate stream about how to deal with jet lag and flying stuff. But
So
you get this really short night, like really short, because you leave at like 4 or 5:30 in the afternoon. You fly for 12 hours, but your night's only 2 hours long, and then you wake up to breakfast coming into Heathrow.
but there's just so many problems with the flat Earth. You have to come up with so many contrivances to make it work. You know, figure out a system that's simple and consistent. That's if you're dealing with engineering matters or physical reality. Yeah, that's probably true.
Well, I mean, as fun as it is to clown on tards, and it is fun to clown on tards, which is probably why Nick suggested this. We've been super serious for a while now with everything going on, so clowning around a bit, it's fun. But look at how we attacked the problem. This is, I guess, kind of an episode on how to think about thinking. You know, look at all the different ways that we attacked the problem, and note that I said though, we don't expect to convince anybody, because we can throw all the facts, all the logic, all the data. We can throw literally everything at a flat earther, and you know what it will do? It will convince them that they are correct. It will.
Man,
All right.
you know what this reminds me of?
Hmm.
Trying to convince my ex-wife of something.
Yeah.
Yeah. My ex-wife, it definitely reminds me of that. My current wife, she's kind of figured out that it's probably a good idea to listen, but even then, she still tries. It is human nature to want to believe that
Right.
you have
That's
the
what I
inside
want
scoop.
to point out. Yeah.
Yeah. So really,
Facts don't matter. I'm still gonna hold on to my opinion. Okay.
right. So really, this is all intended. Yes, we got to spurg out over all the data and all the cool visualizations, and I got to talk about flying a lot, which is I always love doing. And I think Nick might have known that when he suggested this, but um, but the point is that we are not actually trying to convince any flat earthers of anything. Yes, we have presented what I think are some very strong arguments. You know, real-time video feed from a rocket is just about as good as we can get. And but you know, I brought up the windows on the airplane. You can put a flat earther in an airplane and they will still come up with a reason why the earth is flat, despite what their own eyes are telling them.
Might as well
Okay.
just pluck them. No, I mean, I won't say that, but you know.
Nick going
Might
old,
just do something
Old
crazy
Testament
like
on us
that.
here. But
I mean, I'm not using them, so their eyes nor their mind. So, you know.
well, yes. So the point really is to say that, you know, we talk a lot on this channel about, you know, facts and data and, you know, what should we do about it and how should we attack it. And I guess really, at least for me, this is a little bit of, we're having a lot of fun, we're making a lot of jokes, but it's a reminder that no matter how much evidence that we throw at the system, people are just going to go on believing what they want to believe. So it's a little bit of a
The
self-deprecation.
transformer effect.
Yeah.
The
And no
transformer
matter
effect.
how much red pill knowledge you throw out, you're not going to convince the majority of people. I
We're
mean,
not going to
and
convince
there's
the majority of
different
men, that's
takes.
for sure.
there's different takes on it too. Some are going to view it this way, others are going to view it that way. Some will take into account the biblical and incorporate that in and come up with a thought and a basis for their reality.
And
It's
some won't.
all different. And not, you know what? You here's the deal. You can't convince anybody else that you're right and they're wrong. Just not going to happen. They are through life circumstances. They're going to have to, if they change their view, not necessarily to yours, but if they change their view, something happened where their system didn't work. Now they got to change it. That's what causes them to change, not your argument. At least maybe 5%, 10% your argument, but 95% what happened in their life.
Well,
That's how it works.
Steve, I kind of view it this way. I can't change their mind. And I accept that into my soul. But if you give them the data, if you give them the facts, if you give them the charts, when that experience comes that forces them to start reevaluating, if they've interacted with this stuff before, they're going to go, oh, I've heard this from somewhere else. I need to go look this up. I need to go read about this. It's not about trying to, yes, we love facts and figures. Two of us are engineers, but we're not trying to engineer people into anything specific. But when somebody does come around and says, oh, then they can say, yeah, and these guys told me what the facts, these guys told me some facts that I hadn't heard before. I should go check them out. And then they can do their own research.
Concepts, thoughts.
Yeah.
You know what? I'll say that a lot of what we talk about is not facts. It's opinion. It's based on our experience. Some of it's factually based.
Yep.
A lot of it is not.
Yeah.
It's anecdotal. Okay, well, we all believe in a lot of things because of experience. And when you try and convey your experience to someone, it's an anecdote, not facts. Once it leaves you, it's no longer a fact, it's an opinion. And, okay, you're giving them something to think about. How many times have I said that? I hope I gave you guys something to think about. So today was just fun because it's an exercise in thinking about something. And we approached it and we brought up a whole bunch of different things and our own views. And hey, how's it relate here? How's it relate there? Gee, it doesn't work here or there. Okay. That's a good way to just approach anything.
Come now and let us reason together, saith the Lord.
Oh, so they're supposed to have an ability to think. Okay. Man has the ability to think. Oh, there you go. Use your heads.
And not your little heads. Well, this is a red pill channel. I can say that, right?
Yeah.
Yeah, I had a ton of fun. I had a ton of fun getting ready for this one. I had, being able to spurg out a little bit about topics that I care about outside of this space. That was fun too. And, I don't expect to, as I said, I don't expect to convince anybody, but putting this out there, having a good laugh with, our community, our small community, that was a lot of fun. And sometimes we get so caught up in the serious nature of what we're working with that we forget to have a good laugh at ourselves. Like, I know that no one is going to take this stream and listen to it and say, oh yeah, you're right. My flat Earth belief. It's wrong. I should give it up. The globe Earth guys, they're right. No one's gonna. Now, somebody, Tacticus, I think you said much earlier in the stream, that we should send this to Owen Benjamin. If you want to do that as a troll, you have our fervent permission and encouragement to go do that. Just as a troll.
Man.
But
Hey, and it's
That
perfect for the
could lead to some
Thanksgiving thing.
interesting things.
yeah. Yeah. Exactly. This is perfect for the Thanksgiving table. You can do as Nick did this for this whole conversation. He noticed he didn't say a whole lot this evening. He just kind of rolled the grenade across the table and then sat back and watched as everyone reacted.
Oh,
You
know what? Owen needs some new rant material.
Oh, Owen needs new rant material? Okay. Well,
He
Owen,
always does.
Here it is. There you go, Owen. Tacticus, feel free to send it on to him so that he can rant at little old us.
Yeah. And say hi from Plutarch Bear, Unplugged Bear, and 7-Man Bear.
Yes, please do. I know we normally say, oh, if you liked what you heard this evening, share our streams. But in this particular case, Owen can have this stream served up on us just for him. So,
Hey,
yes,
we came after the flat earthers today.
we did. Oh, he really has too. It's kind of. Do I want to use that word here? The amount of time that guy spends spiraling over the flat Earth, which is by the way, Shu, great pun. I love it. Spiraling over the flat Earth. Yeah, he needs to get a new hobby. Honestly, like one of these days, somebody is going to get the idea, and it could be Musk, to stick a whole bunch of these flat earthers on a starship and just send them up and say, here you go, guys. There it is. There's the globe Earth. Just as a giant, I mean, Musk could afford it, and just as a giant fuck you.
I think we should just send them to Mars as the first colonizers.
Oh, that's actually not a terrible idea. I like that. There you go, guys. That's our actionable idea for the evening. We're gonna rack up all the flat Earth people, and we're gonna strap them to a starship and send them to Mars. There we go. Musk, if you're listening, please do this just for the lulz. So, guys, that's all I have for this evening. There's so much math you can do. There's so much evidence out there for it. We've only scratched the surface of it. But, don't forget to have fun at your own expense sometimes. Don't forget to have fun. And we're not doing a stream on Wednesday, so we'll see you again next Monday, I think. Yeah. We don't have anything planned yet because we're like that sometimes. We'll get there. Steve hasn't done a Monday show in a while, so he's probably on some ideas.
I was thinking that's probably my turn.
I do know that next Wednesday, I'm actually looking at leading a CCS, so we're gonna put Nick on an island for a while he's got his kids. So I'm gonna be doing a CCS on dancing monkeys and short-term culture. So,
okay,
yeah. So we're gonna have some fun on Wednesday next week. Monday, we'll have to figure out what it is that we're gonna be doing. But and now Nick's like,
I know where that's going. I think I know where that's going.
Yeah, and now Nick's like, damn it, I want to be there for that one. So, and if you guys had fun, and you want to hear more from us, well, sorry, we don't do streams like this all that often. We are a bunch of serious people. who talk about serious things most of the time, but occasionally we do. And if you do want to hear some of our more serious stuff, you can leave a subscribe, and we do this every week, rain or shine, cold or heat, Coriolis effect or no. I am sure that there will be plenty of comments about how we're horrifically wrong about the Earth. And so those you can leave in the comment section, where I or one of my brethren on screen will promptly round file them. And if you enjoyed the video, if you had fun tonight, go ahead, leave us a like. And yeah, this was a lot of fun, guys.
Okay.
Any final thoughts?
No. You got
No.
everything for me.
All right, then
Happy
we will
Thanksgiving.
see. Yeah, we will see you all next week. We are skipping Wednesday because you all should be out with your families anyway. Yeah, we'll see you on Monday. Bye.
Bye.